This is WPSL Port St. Lucie, the talk of the Treasure Coast.
Funny thing happened on the way to the studio. Can't get in the building. Florida Power and Light they're doing a masterful job of hardening things up for the next hurricane. And all of the poles on our street are coming down. Oh, my. And yeah, nice to be able to start Money Info. Brought to you by Princeton Research with Charles Moskowitz in Boston, Mike King in Las Vegas. And a very pleasant good morning, guys.
That's Boston, the home of the future world champion Red Sox.
Oh, please. Just because you swept that small market team over the weekend.
It's not that.
No.
I was more impressed with the fact that they have clearly displayed that they can come from behind.
Oh, yeah. There's no doubt about it.
I mean, it was 4-1 in the bottom of the ninth.
Yeah.
In the last game.
Yep.
It's just been amazing the amount of offense that these guys are putting together. And how about the new guy, Dave Pierce? Brought him in, I don't even remember from where, shows up and hits 3 home runs in the first game against the Yankees.
Not a bad debut. Yeah.
No joke.
Did you, by the way, speaking of baseball, did you, with everything that's going on in politics right now, right? There's a great headline in the Daily News a few days ago. Deport the New York Mets. Oh, God. I couldn't believe my eyes. I'm sitting there going, oh, my.
Every dog has its day. It's not just stocks that work that way.
Yeah. Oh, my. Well, it's like the market seemed to be doing some interesting stuff, and then all of a sudden all this tariff crap, and guess what? The markets go spiraling again.
It's funny, and they did take it down, but the Dow's up 161 today.
Oh, geez.
25,664.
Okay.
Which is basically a day or two striking distance to new all-time highs. The S&P, which I think the high was 2872, is currently 2864.
Wow.
NASDAQ has made new highs, as has the Russell. Even the transports are acting better. And so, this is, and traditionally, historically, August is the worst month of the year.
Wow.
Or August is a very bad month, and it starts the worst 3 months, August, September, October.
Okay.
But it doesn't seem to be working that way.
Well, and it seems so weird, and you've got all this bizarre stuff surrounding Facebook. Now they're talking about getting into like dating site, and Tom Sullivan yesterday had something shocking where they want Facebook wants your banking information.
Yeah, I wrote about that in the note last night.
Okay.
And my one question about that is, what could go wrong?
Yeah, you're right. Exactly.
I mean, because they've been so on top of securing our data, why not just give them all the banking stuff too?
Sure. Yeah.
Because that's only as important as, let's say, what some millennials ate for dinner last night, or what my 16-year-old granddaughter thinks should go, into the public domain. Give them the bank stuff too. Why not?
It all works for me, comrade.
Yeah, right. And in the meantime, the stock was up $7 yesterday.
Oh no.
Which puts it back into the gap. I mean, it's a long way from the 217 it was before the earnings came, or the lack of earnings came, and the warning. But this is a very interesting market. I mean, I'm seeing, lots of stocks that are still underperforming, and not because they're bad, just because they're so, out of the focus. They're not Biogen or Texas Instruments or Apple or Facebook or Baidu or any of those. And so there are a lot of opportunities. And I've also noticed a trend in talking to some of the fund managers. A lot of their customers are looking to kind of go small as it relates to who manages money. There are plenty. Well, look at us. I mean, we've had a terrible 6 weeks, and we're still up 68% year to date. I mean, that dwarfs anything that the big guys do.
Wow.
And part of that is because we can be nimble and move in and out of stuff that, a guy with $12 billion under management can't touch, because there's not enough liquidity. I mean, even we have problems. I really like a company, Dillard Department Stores.
Oh, yeah.
And I've liked it since it was about 76, but it's 82. The problem is there is no liquidity in the options. And when I say no liquidity, as I can say it, if you try and buy 5 or 10 at a time, you can do it. If you want to buy 20 or 50, which is not that big a position, you just can't do it. I mean, these things are, 70 cents bid offered at $1.05.
Yeah.
And they're probably worth something in the middle. But, there's plenty of stuff out there that is not tariff-related or international trade. And that's probably one of the main reasons why the first of the major indexes to continually make new highs has been the Russell 2000.
Well,
they're all U.S. companies.
Yeah, I'll tell you, Charles. You mentioned Dillard's. We happen to be picking something up at the Simon Mall next to us, and man, you could shoot a cannon down that mall. There was nobody there, and of course, Dillard's, Macy's, and Penny's are the big stores, and it's like, wow, it's usually busy in here. There was no one there. That's a little scary. But hey,
yeah. I mean, we've been talking about that for 2.5 years.
Yep.
It amazes me that Simon has held up as well as it has. Same thing with Tanger outlets. I mean, these are all the premium outlets and premium malls that continue to do well.
Well, Tanger, as a matter of fact, it does continue to do well. The one in Vero Beach, I mean, it's always jammed. The outlet mall. Yeah, oh, you bet. Yep. And,
you think about it, they built these big malls so that we wouldn't have to be worried about weather or parking or, whatever. And then you turn around and you see these outlet malls, which are completely outside and and unprotected, and they're the ones who are doing the business. So It isn't always about the convenience for the shopper as it is for the bargain prices that people expect that they're getting there.
Well, and you were talking, it was well over a year ago, on how much you personally are buying, including shoes, on the web.
Yeah, absolutely. And so, the shift has been evident. And it's, the interesting thing, Greg, is that as a percentage of sales, it's still minute compared to brick and mortar. I mean, as big as it's gotten, as fast as it's gotten, it's, still not much. And I'll tell you something else, which I found really interesting, and you'll be the judge. I have been spending more of my food dollars at Whole Foods because my Amazon Prime is hooked to my phone, and I input the phone number, and I get further discounts on all kinds of things. And every once in a while, they'll have a day where everything is 10% off, and the prices have already come down. So, it's not like they're giving me a couple of cents here and there. They're giving me a couple of cents on everything throughout the place, and then they're further giving me 10% on any of their sale items and, up to 10% of complete orders. I mean, it's pretty amazing.
So
anyway,
signing up,
signing
up for Amazon Prime was a good deal for you then, huh?
Oh, yeah. Well, not only that, but I know my FedEx and UPS drivers by their first names because my wife, there's a package or two or three here every single day. So, yeah. Hopefully, I'm not that unusual as it relates for these guys.
There you go.
But I do want to mention that the guests that we have today are from Precision Therapeutics, which was Skyline Medical, a company that we introduced some time ago. And we've had them on once since then for an update, and I thought that it would be an advantageous time to have them on again because of, some things that have happened. And is Jerry Varzel on yet?
Yeah, Jerry's here, and Mark Collins.
Great. Okay, so before we get started, before I introduce them, I just want to read you a short disclaimer. I'd like to caution that comments made during the show by management will contain forward-looking statements regarding the operations and future results of Precision Therapeutics and Helomix Corp. Encourage you to review the company's filings with the SEC, including, without limitation, its 10-Ks, which identify specific factors that may cause actual results or events that differ materially from those described in forward-looking statements. Any forward-looking statements should be considered in light of these factors. Please note, as a safe harbor, any outlook we present as is of today, and management does not undertake any obligation to revise forward-looking statements. See, now, if I were on TV, we could have sped that up and half the time, and nobody would have understood.
Yeah, well,
but
and our lawyers in Washington, D.C. were taking down every word of that, by the way.
Yeah, but all that said, this is a really exciting story. The stock is inexpensive by most measures, and on a raw price, the symbol, by the way, is A as in apple, I, P as in Peter, T as in Tom. It's $1.20. It's unchanged on the day. I think that when we started with Skyline, the stock was under $1, and we had an issue with NASDAQ at the time, all of which was cleared up, and the stock has performed well. I mean, 20%, still 20%, and it has been higher, but the story is really exciting, and, from my perspective, it looks to me like a much more expensive stock just kind of hiding in where we are today. So, Jerry, why don't you start, and we'll discuss this as we go along.
Yeah, thank you. We're excited to be back on, and as Mark and I speak today, just as a disclaimer, is on behalf of Helomix. As you are aware, or maybe since the last time we've talked, of course, Precision Therapeutics signed a definitive merger agreement with Helomix. So we're excited. We're moving down that path. We started out initially with Precision Therapeutics, and we continue to execute our strategy, which is on the AI front, the bioinformatics front, as well as our precision oncology insights. But as we all know, Right now, a lot of folks, a lot of companies are speaking highly of artificial intelligence and bioinformatics and how that's going to drive precision medicine. And, one of the things that we have been communicating over the past 18 months is our database, our GPS roadmap. And we're excited where we are today. We've made substantial steps forward on our D-chip, which is our AI-powered bioinformatics platform, and our Precision Oncology Insight business, which allows us to bring in new tumors every single day. So we're excited to be on, Mark and myself, and we're looking forward to closing the merger with Precision Therapeutics and continue to move forward the remaining of 2018 and driving 2019.
That's great. I don't think people really understand, or maybe they do, but for new listeners, the ability to do what it is that Holomics does from the standpoint of maintaining and expanding a quantitative and qualitative analysis of tumors in their database, how important that is, and the fact that this generally is aimed at women's problems, ovarian cancer specifically, which is kind of a problem for them only because there's not a lot, or there can be not a lot of symptoms until it's fairly serious. So having the ability to, test tumors outside the body without the effects of some of the stronger or more experimental chemo is really a tremendous value. I mean, it takes a lot of the kind of guesswork from the diagnostic side that maybe something will work, maybe something won't work. These are, everybody has different reactions to these things. I mean, it really takes it down and increases the level of comfort of the patient.
Yeah, this is Mark, Cam. So, I think you gave a very nice explanation, actually, of our business. And it really is the point that we're really trying to position ourselves as a precision medicine company. I mean, when the patient, we get a patient tumor sample, obviously the patient already has cancer. So what we're trying to do, as you nicely explained there, is be able to determine the best course of treatment for that patient based on actually testing their tumor. And that's what's really unique about the Holomics approach, and something that we think is extremely valuable moving forward, particularly when you marry that together with genomics, being able to understand the mutations that are driving the tumor, and you pull that together with machine learning, artificial intelligence, which is some of my expertise, and be able to leverage all of the data that we collected over the last 15 years of doing clinical testing and use that to really help women with ovarian cancer in particular, achieve better outcomes, or help their oncologists achieve better outcomes for those patients. Because as you rightly pointed out, ovarian cancer is called the silent killer. You don't experience many symptoms, and the symptoms that you do experience are often, normal for the age of that woman. Yet, if it's caught relatively early and you get the right treatment, outcomes are usually pretty decent. 5-year survival rate is pretty decent. But again, what we're trying to do here at Holomics, as Jerry explained, is really bring together multiple elements of what we've done in the past, together with a new strategy to become, as it were, company that's in the precision medicine space that would be, mentioned together with Foundation Medicine and companies like that, which just focusing on the genomic side of the world and don't have the drug response testing that we have.
I think it's part smart business from the Helomics side, but the fact is, joint ventures with all of these other hospitals and universities, and of course the teaching hospitals, make it, a little bit better or easier for us to continue to gain in size what we actually have relative to different types of tumors going forward. I mean, the teaching hospitals are more than happy, I assume, to ship us samples, and for us to be able to continue to grow that library of information is really terrific. It's kind of funny from the valuation side of the stock, because let's face it, we're not in this solely for the altruistic point of view. What I find interesting is that the focus on machine learning and artificial intelligence has been focused primarily not on the companies that are using it, but on the companies that are making it possible. The AMD and
Great point.
NVIDIAs of the world. And as this proliferates as a way of helping in the medical business, I would assume that over time it will filter down into the companies that are actually using it. As I said, up until now, if it's not NVIDIA or Intel or AMD, you don't really hear about it on a day-by-day basis. But you can be sure every time NVIDIA puts out a press release or has an earnings report, they rely very heavily on the proliferation of machine learning, AI, in all of their press. So I think, from the standpoint of the greater our library and the more helpful we can become, it becomes more evident. And, it's my personal theory that I would expect that it will filter down into the companies that are actually doing stuff.
So, guys, your opinions on artificial intelligence and what it's done for medicine and, and fighting these horrible diseases like cancer.
Yeah, so it's interesting because I spent most of my career in and out of artificial intelligence, and each time it's been, seen as the great white hope of everything. Back in the 1980s when I first started working on machine learning, we were using it to design chemical structures for drugs, and I held some fundamental patents in that space. And then we started to apply it as we got more data from in drug discovery. We were able to apply AI to that. But where AI really, machine learning really started was things like speech recognition, things that we take for granted now. Were the sort of first revolution of machine learning AI. Vision, machine vision. I work particularly on machine vision, looking at how you can tell what a cell is doing by imaging it. So I think where we are right now is that, and Cam, it's a very insightful observation you made, is that AI is seen as because it's now reached what I would say the level where it's sort of broken out of the lab, right? I don't need to be a PhD computational scientist to use AI. I can be, a business analyst. I can buy from Amazon or Azure or whatever, cloud service you can name. I can buy machine learning algorithms and machine learning compute power, by the minute, by the hour. So really what it comes down to, the clever bit now is having the data and understanding what that data is telling you, and understanding what the machine learning applied to that data can give you. So we're starting to see people use machine learning to do what's called real-world evidence. So looking at big data sets from hospitals on, different procedures and whether those procedures make sense, whether they're cost-effective or not. So there's a lot of data out there that is really waiting for talented data scientists and talented machine learning and AI applied to that data to give us some help. And obviously, there's the big, IBM Watson and so on. That's often talked about. It doesn't do a bad job at all. And again, it can also be fooled. So again, the quality of what machine learning can do is dependent on the data, and that's where we really have an edge. Is that we're not going out. Every day a new tumor comes in that brings us new data, but we have 150,000 cases in our database spanning 17 different kinds of cancer that we can already begin and are applying machine learning approaches to learning as much as we can about that to help both clinicians make clinical decisions, which is really where we see AI making, I think, a big inroad, is not replacing clinicians. We'll never do that. Probably never should do that, but really augmenting, right? So years and years ago, I remember reading an article about machine learning and artificial intelligence. It's all about augmenting human capabilities, and that's what AI allows us to do. So a clinician, for example, using our system, can leverage 150,000 cases to compare his case of his patient to, and have the machine learning system, D-chip system, sift and filter and give him recommendations based on those 150,000 patients that he'd never see that many patients in his lifetime, right? So that's where we see some of the power of machine learning, is in interpreting big data sets, helping clinicians, payers, insurers even, hospital systems, policymakers, make decisions based on sound evidence and lots of data. And also from our perspective, we see the machine learning having an impact on future therapies as well, right? So
why don't you explain what the D-chip actually is? Because I don't want people to think, we're in the commodity chip business. It's a
no, that's right. No, it's an acronym that stands for Digital Clinical Health Informatics Platform. So what that is, it's a combination of de-identified, anonymized data that we've acquired on patients with cancer that have been tested here at our facility here in Pittsburgh. Their tumor's been tested. We've tested the drug response of their tumor. That's in the database. We have certain amounts of clinical information in our database, and we also have what you might call biomarker information. So what key mutations their tumor has, and so on. All that information forms part of the D-chip database, and then there's a bunch of machine learning algorithms that interpret that data and serve it up through a web portal, a web-based application that eventually an oncologist will be able to use. At the moment, we provide a static report back to the oncologist. But also that D-chip portal, the web part of the world, is is also open to our pharma partners to use as well. And that's quite an exciting development in that pharmaceutical industry, I know I worked for pharma for a long time and cured a lot of mice of cancer. What pharma industry is really interested in is data about patients with cancer. And we have a unique database of drug response profiles that they can, subscribe to and use that to, design new drugs, look at new ways of diagnosing or testing for cancer, or indeed look for new markers for their particular, drug, a sort of companion diagnostic.
And it's a symbiotic relationship. I mean, we're giving them something. We're giving them access to something they may or may not have. They certainly don't have it in quantity and qualitative analysis. And of course, we're collecting more samples and increasing our ability to give good information to these people.
Yeah. And we can also, use the DCHIP framework that we have to bring in, their data to add to it as well. So if they, for example, say, well, we're interested in a breast cancer project, you have a lot of data on patients with breast cancer and how their tumors respond to drugs. We have some, maybe some genomic information. We also have some data from, patients on a clinical trial. We can bring that data in. Our framework uses the very latest in what are called graph databases, which, are all about relationships. We're able to bring that data in and use it to power, perhaps more insights than we could just get from the data that we already have. So it's not a static thing. It's a very dynamic thing. We get more data into it every day because we're testing more tumors, but we can also bring in a pharma company's data. We can bring in data from a medical university, for example.
Diagnostic companies,
and those all go into the mix, and we're able to use that to answer the questions that those companies are interested in answering, which is usually, does my drug do this? Does my drug do that? Will it work on these kinds of patients? And again, this allows us to do much more precision medicine, right? So we, instead of saying, well, we think this drug will work on patients who have breast cancer, we can now say, well, for patients who had recurring breast cancer that was, resistant to this type of chemotherapy, we can find in our database, and we can model out.
And for people who don't,
people who think that this is all heavily involved and in the corners of the business and beginning to grow, are wrong. And the clearest anecdotal evidence of that is there are even TV commercials for new drugs that specifically say, if you have this gene and that marker, this is the drug for you. And to see the proliferation of those types of ads in the mainstream is just, further, I don't want to use the word vindication, but it's just, one more anecdotal piece of evidence that this is the way that things are going.
Yeah, I've got a question on that too. Is like, say a diagnostics company comes to you with a study, and how long does it take the artificial intelligence and of course your entire library to get back to these people? Is it hours, days, months? How does that work?
A typical project, depending whether we're doing wet lab work for them as well. But if it's a pure in silico project, where we're just, maybe answering a question for them. I mean, that's the purpose of what I mentioned the D-Chip portal is. That's a self-serve. They can go on there, ask questions of the portal, what are the profiles of patients with, these certain kinds of cancers? That's, minutes to get an answer there. If they want to use some of their own data, it's typically, days to weeks. It's certainly not months.
That's great.
Once we have the data, it's quick. It's pretty quick.
If it's wet lab, it's longer.
And if it's wet lab stuff, it takes longer. It just, there's only so many machines we can we can run 24/7, even with automation. So
sure.
So typically, if it's a pure in silico project, tell me, for lung cancer, what are the drug response profiles of patients, who have stage 2 recurrent non-small cell lung cancer. We can tell them that in a few minutes, and they can even ask the D-Chip portal themselves if they're subscribing to it. If they want to bring in their own data, it takes us a few days to curate that data and load it. But then the machine learning algorithms are pretty quick. And again, what's nice now is when I first started doing machine learning, we had to use specific processing boards in our computers to even, bring the processing time down to days. And now I can, using Amazon, for example, and compute resources, I can assign, 100 different computers to that problem for 3 minutes, and then only pay for those 100 computers for 3 minutes, and then blow them away at the end, and I have my answer, and I haven't spent a gigantic sum of money doing it.
Wait a minute, back up a second. You said using Amazon. Are they this is something I don't know. They're into all of this as well.
Oh yeah.
Really?
You can buy machine learning appliances. In other words, a virtual machine, a machine that exists only in software, to run. And we do this. We do this at Amazon and Azure. We can buy that by the hour. So if we want to train an algorithm to understand the relationship between the genotype of the tumor and the drug response, the phenotype of the tumor, we can do that by the hour at Amazon, and we're just paying for the time we're using. That's all using NVIDIA chips on the back end, but we're insulated from all of that. We don't have the overhead of buying all that stuff, configuring it all. We just buy it by the hour as a commodity, essentially, which is what's really exciting about this generation of AI, having gone through 2 or 3 other iterations of AI in the past, where you literally had to almost build your own computers. Nowadays I can buy it at Amazon by the hour, or Azure by the hour. Amazon's a little bit more sophisticated and easier to use, but Microsoft will get there with Azure very soon. It's a commodity, right?
Oh, this is amazing.
So then what it becomes, right?
And people wonder why Amazon sells where it does.
Yeah.
Exactly.
Yeah.
What this points out is that it's no longer about the AI per se, right? It's about your expertise, the data that you have, the data that you can, the way you represent the data to the machine learning is where that's where the expertise and intellectual property and value comes from, right? I've worked for different companies over the years in AI, and when you're a pure software company building AI algorithms, you're always hungry for data, right? Because these are data-driven algorithms. You can't test them without data. So, now we're in a very unique position here at Holomics with having a huge database already. A lot of other companies are going out there raising money, a lot of money, and building partnerships with universities and so on, which is the right thing to do, of course, just to build their database, to get started. We have this massive database already, and it's a vast database of how a tumor responds to drugs, which is an extremely valuable thing to know, right? It's important to know the mutations in the tumor, but it's even more important to know how the tumor responds to drugs. That's what's going to help you drive clinical decision-making. Knowing what mutations the tumor has is important for those very small number of drugs that, as you pointed out, are advertised as, if you have this mutation, you should get this drug. The sort of reality of precision medicine is, at the moment, we don't have very many of those drugs. We have about 6 of those drugs that are tied to particular mutations. So if you don't fall into that camp of having those mutations, you won't get the drug to begin with. Even if you do have that mutation, then the drug may not be effective for you. And in most cases, it's not effective. It's only about 30% of cases it is effective. Whereas our approach is, we understand the mutation of the tumor, but we're also going to dynamically take your tumor, test it, see its profile, how it responds to drugs, and then compare that response profile to the other 150,000 response profiles we have that our machine learning system has learned, and give the clinician a really, as Jerry said at the beginning, a roadmap for your patients like this patient, these patients, treatment roadmap went like this and they had this outcome. That's really where, we think this idea of functional, what we're calling functional precision medicine, is we really see as the way forward that combines both genomics, which is extremely powerful, but it combines genomics with testing the tumor, as it were, poking the dog to see how it reacts, is the best way. That kind of fell out of favor for a while because genomics was seen as the holy grail. But I think there's a lot of people now, from Dana-Farber and MGH and Harvard and so on, Cornell, saying, well, maybe genomics isn't the only answer. Maybe we should do more testing on the tumor itself. And we pop up and say, yep, we've been doing that for the last 15 years, and we got a big database of it, and we can interpret it in novel and interesting ways to help both drive clinical decision-making now for patients that have cancer now, but also drive the generation of new therapies through using that data in partnership with pharma and diagnostic companies.
Well, I would... go ahead, Charles.
As long as we're on this and we're talking about patients, can we discuss the right to try legislation that has been passed?
Yeah, this is Jerry speaking. The Holomics approach for the past 10-plus years, has been essentially the right to try to the patients. And we do that by testing the standard of care drugs on the patient's own tumor cells. So, this has been shown to improve patient outcomes. So our initiative is, as we look at, our core ovarian and breast, but as we look outside that into some of the other disease categories, we feel that Holomics has a huge, meaningful part in taking precision medicine approach that could significantly impact the implementation of that. And one of the things that we're excited about is how can we align that, and basically you got a right to try bill that's out there. It's already been signed by the president, but how can Holomics fill the middle part in terms of bringing some of those tumors in and really minimize the risk while positively impacting patient incomes. And that's where we feel that we have a significant value-added approach because of what we've been doing over the past decade of bringing those tumors in, testing to a standard care of drugs outside the patient's body. And as we go forward, if we could assist across all the stakeholders, that being the patient, the clinician, the regulatory and drug companies, this would provide a meaningful step forward to impact those patients and be able to drive that. So we've been talking to folks. We've had some meetings in Washington early. We want to make sure that we can continue to build off of that. And by no means, when we talk about right to try, I mean, we're talking oncology. I mean, there's other areas. But, one of the things that we see here is really, if you're in that situation, you talk about false hope. Well, if you have no other means, and you yourself, when we talk about personalized medicine, any type of hope is something. Think about, I'm sure we all have loved ones or someone we know. But if we can have a meaningful impact in giving something back to this right to try bill, and while minimizing risk, granted, there's drug companies and the regulatory folks, but to be able to test outside the tumor those drugs that we could provide something back to the clinician that can help provide a roadmap for those patients. That's an exciting thing for us. And when we saw this, we've been following the right to try bill, and then when it moved very quickly to get signed by President Trump, we thought it was, even though the bill's signed, we had a meaningful approach to be able to have some substance to the actual deliverable.
Yeah, because I think when we talked to the folks in Washington, what was clear to us was that the bill passed, but then everyone pats himself on the back and says, yeah, the bill passed, but it's really is it going to actually have an impact? Is it actually going to be translated into something that's actually useful? Because the reality is that the FDA approves 95+% of what are called compassionate care orders, which is when a clinician says, "Can I try this experimental drug on this patient?" It's a sort of last hope type of thing. The FDA approves those. Then it goes into a sort of spiral where the drug company gets involved, the drug company's lawyers get involved, and that tends to hold. The insurer probably gets involved as well. And as Jerry said, what we're trying to do here is provide a path through that by saying, well, we can't completely de-risk this process, but we can say, minimize. Here you go. If you have a patient sample, a patient tumor sample, we can test that experimental drug. We may have already tested that experimental drug on a patient tumor, and so we have some idea of whether it may or may not work. And that, we think, as Jerry said, gives a path to implementation that satisfies, the various stakeholders. Patients get an understanding that the drug will work on their tumor. The data collected from those right to try requests, we can provide, to drug companies and to the regulatory authorities, again, to show that, that drug might have an effect.
Okay, guys, we are coming up against the end of the show, so I just want to do a little housekeeping here and tell everyone, remind everyone that the symbol for the stock is A as in Apple, I, P as in Peter, T as in Tom. The website that was recently launched is precisiontherapeutics.com, all spelled out. And is there, are you still using the separate Helomics website, guys?
Yes, we have that up and running. Yes, we are.
Okay, and that's Helomics, Helomics thethreadinc.com. And we'll
That's correct,
definitely
yeah.
have you guys back because, you know,
Wow.
things
Yeah.
in this area change so dramatically. And the stock, by the way, as I said, AIPT, is $1.22 bid, offered at $1.25 now, and the last is 122.7, which is up about 2.25% on the day.
All right. Hey, Charles, maybe as an Amazon Prime customer, you can get them discounts on the Amazon computer.
Yeah, right.
Well, thank you, gentlemen, for letting us be on the show today. We always appreciate it. Exciting times, and it's great to actually be on some shows that's like yourself that understand the space and where it's going. So thank you for the questions, and we look forward to coming back again.
Boy, I hope
Great.
so. Yeah, don't be a stranger. This is
Absolutely.
amazing. Charles, grand slam on this one. Hey, we'll talk to you next week. Charles Moskowitz in Boston. Money Info, Lomax, and PrecisionTherapeutics.com. Wow. I didn't even know Amazon was artificial intelligence. Naturally, what aren't they in? This is WPSL Port St. Lucie. WPSL on Google Home. WPSL on Alexa. WPSL on Echo.